Hello, my friends. Welcome back. So today we're going to learn about a technique called separation of variables. Now, let's first off set the stage for what this is going to help us find. So, a solution to a differential equation. So now we're going to talk about an algebraic solution rather than just like a graphical solution curve. But how do we get an equation for that curve? A solution to a DE is an equation that makes the differential equation true. Makes the DE true. And what I mean by makes the DE true is it makes the two sides equal to each other. So for example, let's take a look at this. So suppose we have the differential equation dy dx, so the slope, is equal to 2x times y. And I'm going to ask, is y equals cosine of x squared a solution? Now, if you're trying to ask if something like this is a solution, the strategy you want to take looks like this. You're going to plug in this equation for the y and for the dy dx and see if both sides of this differential equation are equivalent. Okay, so let's go ahead and start with this. So we said y equals cosine x squared. So y equals cosine x squared. So when we take the derivative of that, because we need to plug in for that, the derivative of that is negative sine of x squared times 2x by the chain rule. So what I'm going to do with these is I'm going to plug them into the dE. So I'm going to plug them in for this part right here, the dy dx, and plug them in for the y. Okay, so let's plug those in. So when I do that, I'm going to get negative sine of x squared times 2x equals 2x times, okay, and then the y equation right here is cosine of x squared. Are these the same? And the answer, of course, is no. And hopefully you guys can see that. So what that means is y equals cosine of x squared is not a solution. Okay, let's look at one more example now. So same DE, say I tell you dy dx equals 2xy, and I'm going to ask, is y equals e to the x squared a solution? Okay, now here's how you're going to want to approach this. Again, I'm going to go ahead and find y, well, it's right there, find dy dx, and then plug those in to my differential equation. All right, so if my y is e to the x squared, the derivative of that, of course, is just e to the x squared, and then by the chain rule, we'll multiply by 2x. So when I plug this in for y, plug this in for dy dx and my dE, I see, okay, I get 2x e to the x squared equals 2x times, and then my y was e to the x squared. Oh, are those two the same? Yes. So that's what's called a solution. So yes, y equals e to the x squared is a solution. Okay, so what that means is if you have the equation y equals x squared, the slope of that equation is equal to 2x times that equation. And I showed that by plugging in the y and plugging in the dy dx. And I got that the two sides of the equation were equal. So that means that this equation is the solution to this differential equation. Now, you might be wondering and should be wondering, Mr. Boris, where did you get y equals e to the x squared from? Well, that's a great question. And the strategy, the way we're going to do that is something called separation of variables. And that is the main topic for today. Okay, separation of variables. So our goal, remember, with any differential equation is to solve for y, to get an equation for y. So what we're going to do is something like this. Let's suppose now we have dy dx equals x times y squared. And I'm going to ask you to find a general solution. Okay, so what that means is find an equation for y. Equation for y. And here are the steps that we're going to take, and this is a couple-step process. Basically what we're going to do is, first off, we're going to get the x's on one side with the dx, and get the y and the dy on the other side. Okay, so let's do that first. So I know this seems weird to break up the fraction here, but we're going to multiply the dx to both sides because that's going to cancel error. So we'll get dy equals xy squared times dx. Now I want this y squared to be with its brethren on the y side, so I'll divide both sides by y squared. So I'll get dy over y squared equals x dx. Now my goal in this was to solve for y, of course. So how do I get a y by itself here? Well, how do I get rid of the dx and the dy? I could integrate. So what I'm going to do now is after I do this, and this part, by the way, is called separating. My second step is I'm going to integrate both sides. So when I integrate both sides, when I integrate the right side, of course, that's x squared over 2. When I integrate the left side, if you put a natural log, you're kicked out of this class forever. You're integrating y to the negative 2, so that's negative 1 over y. Now, to make our life easier, we're just going to put a plus c on one side. So we're just going to put a plus c, usually on the side with the x's. Pretty much always on the side with the x's. And the logic there is like, if you're adding a constant on both sides, it's the same as adding constant on one side, right? Having a plus 2 and a plus 5 is the same as just having a plus 3 on one side. You can put them in different sides. It's much easier just to put them on one side, and it'll work out better. Mathematically, it's the same. Okay, now, our goal in this, remember, was to solve for y. That was what we wanted to do. So now that we've separated and now that we integrated, my third step here is to solve for y. Okay, and this is just algebra. All right, so I'm going to multiply the y to the other side. So negative 1 equals y times x squared over 2 plus c. And that means that my y is negative 1 over x squared over 2 plus c. Okay. So what that means, by the way, this is our solution, and then we're done with the problem. But what that means is anything that's in this form, so any c you can plug in, any equation that looks like this, is going to be a solution to this differential equation. So if you were to plug that equation in for dy dx and plug it in for the y, those two sides would be equal to each other. They'd be equivalent, like we saw here when we got the same value on both sides. So that's what we're trying to find by a solution, is something that makes a differential equation true. Look at our steps again. We separated the variables. That's why it's called separation of variables. We integrated both sides, just put 1 plus c over here, and then we solve for y. And that step right there, that separate, integrate, solve, that's what we're going to do on all of these problems. Okay, so let's do a couple more examples, and we'll try and see the patterns for what's going on here. But everything, again, is going to come back to this separate, integrate, solve. Okay, so the next one, let's say dy dx is equal to 3x squared plus cosine of x divided by y. And what we're going to try and do now is to find a solution by separation of variables. And of course, when you see separation of variables, that's what we've been doing in this video, the separate, the integrate, the solve. Okay, so I'll multiply the dx to both sides. I'll actually multiply the y by both sides too to cancel those. Okay, so I'll get y times dy equals 3x squared plus cosine x times dx. Okay. If you want to do it in 2 steps, multiply the dx, then the y, that's fine too. So that was number 1. Now we'll go ahead and integrate for number 2. Okay, so we integrate the left side, so y squared over 2. Integrate the right side, x cubed plus. Okay, derivative of sine is cosine, sine x plus c. So I separated, I integrated, and now my last step is to solve for y. Okay, so that's not too bad. I'll multiply the 2 to the other side. So y squared equals 2x cubed plus 2 sine of x plus 2c. You can just turn that into a single variable. It doesn't matter. So now when I want to solve for y will be plus or minus square root of 2x cubed plus 2 sine of x plus 2c. Now, I know this is a little ugly, but again, this will say that if you have this differential equation, anything that's in this form is going to solve that dE. The two sides will be equal to each other. Okay, I want to look at 2 more examples that are going to highlight some different algebraic strategies. Suppose we have this. Suppose we have dy dx is equal to 2y minus 3 squared. Now, you might look at this and be scared by this because there's no x in this equation. All right, well, let's just trust in the math and see what's going to happen. So we'll multiply dx to both sides. So I'm going to get dy equals 2y minus 3 squared times dx. So, of course, dy over 2y minus 3 squared equals dx. All right, now from here, we just have a dx, but we're still going to go ahead and integrate both sides. We separated, and now we're going to integrate and solve for y. The right side's very simple. You're just integrating a 1, right? So integrating 1, I'm just going to get x plus c. All right. Don't confuse that with xtc. That's totally different. Here we're going to want to do a u sub on the left side. U is 2y minus 3. Du is 2 dy. So we're going to put a 2 here and a 1/2 over there. So that becomes a 1/2 integral 1 over u squared du. So that's negative 1/2 times 1 over u equals x plus c. Okay, now this is kind of a mess. So, we're going to have negative 1/2 times 1 over 2y minus 3 equals x plus c. All right, let's deal with the negative 1/2 first. So this is just the algebra now as we solve for y. But as you can see, there's a fair amount of algebra here. So let's multiply both sides by negative 2. So I'm going to get 1 over 2y minus 3 equals negative 2x minus 2c. I'll multiply that to the other side. So I'll get 1 equals 2y minus 3 times negative 2x minus 2c. So I'll get 2y minus 3 equals 1 over negative 2x minus 2c. God, this one's really ugly. 2y equals 3 plus 1 over negative 2x minus 2c. And then we'll divide by 2. Okay, now, the focus is not on the algebra, honestly. It's important to do the algebra and solve for y, but the real important part here is to separate the variables here, get the x and the y's on different sides. Here we just had a 1 dx. That worked out to be an x when we integrated it, and then try and solve for y. I do want to look at one more case, and this is one you're going to see a lot because it deals in the natural log. So, again, let's find a solution to this differential equation, dy dx equals 2xy by separation of variables. And this, by the way, is how I got the equation that I got at the start of class for a solution to this dE. Okay, so we'll divide the y over, so dy over y, we'll multiply the dx over equals 2x dx. So again, that's just me dividing the y by both sides, then multiplying a dx. All right, so from here, we'll go ahead, we separate, we integrate, we solve. So now we'll integrate the left and the right. The integral of 1 over y is ln of y in absolute value, that's important, equals x squared plus c. Now, our goal, of course, is to solve for y. Again, I just put the plus c on one side. So I'm going to raise e to the power of both sides. Now, it's important that I'm raising e to the power of the entire right side. So on the left side, the e and the ln cancel. So I get absolute value y equals e to the x squared plus c. That plus c is still an exponent because I raise e to the power of the whole side. Okay, the next thing I wanted to go over at this point, when we have here this absolute y equals e to the x squared plus c. All right, now how do I solve for this? Well, let's think back to algebra 1. If you had an absolute value of x equals 5, that meant that x could be plus or minus 5, because the absolute value of 5 is 5, the absolute value of negative 5 is 5. So what that means is the absolute value is going to lead to a plus or minus as well. So when you solve for y, your y is plus or minus e to the x squared plus c. And that's how I got the solution at the start of class. Anything that's in this form, this is my form for the solution, anything that's in this form is a solution to this dE. So that's separation of variables, the separating, the integrating, the solving, and that's how we get to that. Okay, thanks for watching, guys. If you have questions, bring them to class, and next week we'll learn how to actually find out what the C is.